You broke the chair, right, Rob? Good morning, everybody.
I look shorter than you for once.
Oh, good. Welcome to Webinar Wednesday. John Resso, Rob Clemens.
Good morning.
We're just going to have a little conversation today. Talk about some heat pump water heaters and a little bit of tankless, more on the heat pump side, just because A.O. Smith just launched a new heat pump and it's got some new capabilities, so we'll touch on that a little bit. With electrification taking place, whether we're a believer or a non-believer, it's happening. We're seeing it every day. I was out on a job yesterday, oil boiler, guy's putting solar at his home, and he's going to put an electric boiler in to cover 50% of the load for the home. Take care of it with solar panels, got a battery backup, and plans on when the boiler's 20 years old now, when it hits its full mature age, going with another electric boiler to heat the home. And he'll probably, we had the conversation yesterday about switching his indirect that runs off of his oil boiler over to a heat pump hybrid water heater. So kind of leads into what we're doing today and just having that conversation. Where are the opportunities? Why are there opportunities? And what's going on in our industry right now that's creating this demand for knowledge on heat pump water heaters. And we appreciate everybody, logging on this morning. If you have questions, on the right-hand side of your screen, you have the ability to go in there. Please ask questions live. If we have the answer, we'll give it to you right now. If we don't have the answer, we'll get it for you. You'll have a couple of additional documents that will be sent to you via email. It'll be we're waiting for one more rebate sheet for like the lower Hudson Valley down through Westchester County. It'll be Con Edison, it will be Orange and Rockland, and it will be Central Hudson areas that are covered. We do already have a rebate for the PSC&G, New Jersey, which is a $600 rebate on the heat pump water heaters, and that will also be added to the list, and federal tax credit 30% of a total of any installation that costs over $2,000. So you could potentially get another $600 there. So ton of rebates going on right now, and I mean that's kind of what's driving this marketplace.
Yeah, so this isn't a process that's going to slow down anytime soon. We are definitely as we get further into the more efficient and greener energy products, this is something that's going to kind of snowball and get larger and faster as we move along. There's a lot of stuff going on behind the scenes where we're really starting to push the entire world towards these kind of products. So we want to give you guys the opportunity to get ahead of it and be able to jump on board before this whole thing starts to take effect more fully.
Yeah, really accelerate. And it seems crazy, but this is our second generation heat pump, right? The other one was like 10 years old. This one came out a few years back, and now we've already upped the game again with the Voltex AL. So what is a heat pump? How does it work? Let's dive into that a little bit here. So this is the existing one now here. This is our HPTU, and basically the gray down is an electric water heater, right? These have two 4,500 watt elements in there, one upper, one lower, and then it works like a normal electric water heater would work, and then everything from the black upwards, that's where the heat pump is. And basically, if you're unfamiliar with heat pumps, or if you've done anything in the mini split world, or anywhere you're taking energy from within a space and transitioning it to something else, that's basically what this does. So up on top of here, we have basically a compressor and a full refrigerant circuit, and we utilize the air within the room to pull across the coil, and then we run the refrigerant through there, and then basically what happens is, as the hot gas comes out of the compressor, there are wraps around the steel inner tank, and then it's insulated around the outside. And what takes place is the hot gases, the heat's going to go to the lowest R. The lowest R is going to be the water. So the lowest R value, so the colder water is going to pull the heat off of that. I guess you'd call that the condenser coil at that point, right? Because that's where we're taking the energy from.
Yep.
So the condenser coil, it wraps around the outside of this tank, and then we'll cool those gases off, and we'll send them back up, take them from a high pressure to a low pressure, send them back across the compressor, and just get that cycle going again. We just need to make sure that we are, utilizing all of that refrigerant, making that phase change so we're not sending liquid back to the compressor. You do not have to be a refrigeration technician or have a refrigeration license or anything along those lines to install a heat pump water heater. I'm going to just pop up for a second here. Everything from here up, for the most part, anything related to the refrigerant cycle, we don't even have ports in there for you guys to get an opportunity to do a pressure check. We'll monitor everything with thermistors. The only thing you'll really go in here, you might troubleshoot a thermistor, you might troubleshoot the fan motor, something along them lines, but if it's anything to do with the refrigerant circuit, this has a full 10-year warranty on everything you see here. If there's a problem with the refrigerant circuit, they're going to replace the water heater. So A.O. Smith doesn't want you to have to, change what you do every day. It's still a water heater. This has a cold water connection on the side, hot water connection on the side. One of the changes with the new AL model, the Vertex AL, not only do you have the connection points on the side, but you also have them on the top. So depending on what type of application it is, you can go top or side port. Now, I will caution you, I don't know if there'll be another generation of it, but a bunch of Phillips head screws takes that top off. That gets you down into the refrigerant circuit area. If you plumb it from the top, try to keep your valves as high as you can, because there's no cutaways on the new ones where the pipes come out. So you're going to have to take this and elevate it straight up in order to get down into the top compartment. So just keep that in mind. If I can put the valves, a foot or 18 inches above the heater, these do get kind of tall, but if you can put the valves up higher, so when you take this top, you can elevate it all the way up if you have to get into that refrigerant compartment, where the heat pump lives. What else you got there? So that's kind of, just a quick snapshot of the tank and what the components are, top and bottom.
Yeah, so basically just a couple of things that I want to add there. We are going to need some sort of, I think, 450 cubic feet of air for the heater to be able to operate properly.
Yeah, this one's 750, the new one's
right. 750,
yeah,
450.
450.
Right.
The new ones are smaller. They change the fan and everything, also reduce the decibels, which is great.
Yeah, so it's definitely going to be more quiet. Yeah, so the best type of environment for these heaters is going to be in the warmer type of environments. The more heat you have around the unit, the more heat energy we can absorb from the environment, the more energy that we can put into the water. So if you have a warm boiler room, perfect application. Do understand that since this is a heat pump, it is going to be releasing a lot of the cool energy into the area. So you're going to have a cool and dry environment. It's basically a really nice dehumidifier system. So,
yeah, especially if it runs a lot. If you use a lot of hot water, that will continue to run. So these heat pumps, whether it's this version or the new version, it's 50, 66, and 80 gallon. The reason for the new AL unit, the Voltex AL, is we've upped the efficiencies. We have reduced the noise volume that it puts out, and we've also did I say that our UEF has gone up dramatically.
Yeah, we're at a 4.02.
Yeah, on a 66.
Number, on a 66.
So what does this mean to you? What does this mean to the homeowner? If this was just a standard electric water heater, think of it as a vending machine. If I took $1 bill and slipped it into an electric water heater, I'm going to get $1 worth of energy out of it. When we get into these heat pump water heaters, I'll take that same dollar bill. If I put it into the new Voltex AL 66 gallon, I'm going to get $4.03 worth of energy for that $1 that I just put into the machine. So that's why the industry is going this way, is because these heat pumps are just so much more efficient. And we do have a chart we can share with you here in a little bit. But big difference, that's one of the biggest differences between this version and the new Voltex AL version. Another difference is this unit is good for operation between 45-degree ambient temperature up to 120-degree ambient temperature. The new one will go down to 37-degree ambient temperature up to 120 degrees.
Yep.
So that's kind of like an overview of how they work. So let's say you're going to go and look at an electric water heater today after we're done chatting. What are you really looking for? What's going to be the difference from a standard 40?
Yeah, it's, basically, the same type of installation. The only thing you really got to take into consideration is going through the airflow into the room. That's going to be the only difference. We need air for this unit, whereas a standard electric heater won't. The installation, even down to the connection point, we have one single connection point into the unit. So you're just doing basically taking out that old heater, wiring it into the new heater, and it really doesn't get too much easier than that.
Yeah, and like again, nothing with the refrigerant circuit. So on the new AL, another thing they did too is they kind of brought all the connection points more to the front. So now your back and sides is almost like zero clearance. So the electric has been brought around, the connection points have been brought around a little bit to kind of let you wedge it into a corner. That's one of the changes. But this is just a typical 30 amp circuit, no different than a 40-gallon electric water heater. The main difference here is if you're going to install this unit and you're replacing a top pipe unit, so electric 40-gallon or 50-gallon top pipe, you're going to have to do some plumbing to get to your side takeoffs. That's the biggest change. If you go with the new Vertex AL, that does have top ports. The other concern would just be your height. So we're looking at 61, 63, and 69 inches tall, depending on the size of the tank. Another little feature here that's just a little bit different. Normally when we're talking about water heaters, you'll take the volume of the tank and you'll multiply that by a 0.8 factor or 0.7 factor, depends on which water heater it is, and that tells you what the usable amount of water is within that tank. With the heat pumps, how they operate, we want to keep those electric elements off as much as possible. So we don't really generate the whole tank's worth of hot water. So just keep that in mind when you're sizing. You'll multiply the tank size by a 0.6, and that'll tell you how much hot water in that tank is usable. So like an 80-gallon holds 82 gallons. Multiply that out, tells you what your usable storage is.
Right.
So that's a little bit different, just something to keep in mind. Depending on your hot water needs, it may not be a bad idea because these are so well insulated to elevate the target temperature within the tank a little bit. Put your mix valve, coming out of the tank, and just trickle that hot water out of the tank. You may want to elevate to 140, 150 degree water within the tank, and then put a mix valve on there so that you get a longer run time of equal temperature hot water. So that's just a little bit that'll make up for that factor that we have to change a little bit from a standard water heater. With heat pumps, it's always good, bigger is better, just because the heat pump will recover slower than an electric element will. But our goal with the heat pump is to keep the electric elements off for as much time as we possibly can. I know we're in the Northeast here, and if you were putting this in, somewhere in the South, let's say Florida, you could put this in, full-blown heat pump mode, and that will be the most efficient operational mode. These will come from the factory in what's called a hybrid mode, which means that we are going to rely on the heat pump to do majority of the work. If the heat pump cannot keep up, our top element will come on. It's just a standard 4,500 watt element, no different than what you see in an electric water heater. And then as we deplete the whole tank, we'll top off with the heat pump and with the top element, and then we'll turn the bottom element on if needed, depending on if the thermistor says it's needed or not, based on the temperatures when we start to satisfy the water heater.
Yeah, absolutely. One of the things, one of the features of our heaters that, that comes with these heaters is if for whatever reason our compressor fails, we're not going to go into a situation where we don't have hot water. The electric heat elements at that point in time will take over. So it is advised every so often to take a look at the heater itself, make sure that there's no error codes across the screen, because those could depict that the compressor itself is not operating or something along those lines. And the homeowner may never notice because the heat elements are going to be operating to continue to provide that hot water.
And that's a great transition right there too, because like we have to educate the homeowner. This water heater is different than what they're used to, right? We have on this one, we have a screen on the top, and we can put a duct kit on this. It has to be purchased separately.
Right.
On the new ALs, both the intake and exhaust are on the top, and the intake does have a screen on there. So it wouldn't be a bad idea just to check the water heater once a month, look at the control, make sure everything is working properly, and then just wash out the screen and put the screen back in.
Yep.
So we make sure if you have to duct this into another space because you don't have the cubic feet of air you need to run across that heat pump, then we should check that screen and make sure it's staying clean and we're running as efficiently as we possibly can. That's
Absolutely.
why they're buying them.
Yep.
So let's just walk through an install, right? I haven't seen any questions pop up yet. Again, if you guys got questions, right-hand side of your screen, don't hesitate. Please throw a question up there. So bring this thing in, a little top heavy, right?
Yep.
It's a little different than what we're used to. Got a little more weight to it. So weighs a little more on the top. We're going to bring it down. We're going to set it up the same exact way as we would a standard water heater. Best practice, right? In a pan. This unit is just a basic unit. The new AL actually comes with a little kit. You're going to plug this kit into down near the lower heating element. There's a little terminal for you to plug in, and that goes down and clips onto the bottom of the water heater. It has leak protection standard with the AL model. The Voltex AL has leak protection standard. So pan, set your water heater in there. No need to elevate it. Put it right into the pan. Hook up your water detection device that comes with the unit. If you want to go a next step further, there's also a kit where if that is activated, it will take the cold water main to the water heater and it will rotate it closed so that if there's a leak within the tank, the most water you're going to leak is possibly what's in the tank. It will shut off the main going to it so you don't end up with an indoor swimming pool, which is a great feature. That is an optional component. Just keep that in mind. If that's a feature you like to sell, it's an optional component on the ALs. Here you would have to use like our Takeo leak breaker or something like that to identify a leak on this version. But the new Voltex AL that you guys see on your screen, right there next to the blue adapter and the valve down at the bottom on the lower black cover, that little wire that runs down, that is just below the rim on that black cover on the bottom. That's what senses the water. If that were to sense water, let's say the relief valve blew off or something, it will give you an alarm, and all you have to do is reset the alarm, power the unit off, power it back on, make sure you dried up the sensor, dried up the water, and you're good to go again. You don't have to replace the sensor, which is important.
Sure. When you're dealing with multi-story, multi-family buildings, this is probably something that you're going to want to do to prevent, because water is going to follow gravity. If for whatever reason there's some sort of failure, we want to make sure that, we're protecting the entire living space in that application. Yeah. So always a good idea to have added protections in place.
Yep. That's a real big deal. We've seen those disasters. So, again, you'll plumb your relief valve down depending on local code. If you can plumb it away from the unit so it doesn't shut the unit off, that's great. If you can't, you got to put it into the drain pan. You got to put it into the drain pan. So you'd make your connections. All your connection points, you're gonna go ahead and tie them in, whether it's top or side. On the Voltex ALs, the sides are going to come capped, and the top will be the open ports. If you're not going to utilize the top, you're going to take the caps off of the sides, put them up top, and then hook them up. One thing with the AL that we've done different, there is a tube on the cold water, and we want to make sure that tube stays in place. So as you're tightening up your hot and your colds, make sure you have a backer wrench on there. We also have it marked. So there's a sticker and a black marker. They stay lined up. That means that the tube inside is in the correct location. First thing we're going to look for if we go on a job site of insufficient hot water is we're going to go right to the cold water inlet port and make sure that they're lined up. That tells us that the drip tube or insert tube, whatever you want to call it, is in the right location, and that we're moving the water in there the way that we want to, and we're not bypassing, the theory of heating the water and how it works with the positioning of the condenser coil around the outside of the tank from our compressor on top. So that's a big deal. So you're going to use a backer wrench. We have a drain on this, a brass drain. You're going to hook up your hot water mains, valve them, whatever your normal install looks like. That's up to you. We love seeing valves on water heaters. Another thing you're going to have to do, and because we have a heat pump on top of here, we are going to generate water. AO does give you this tube, and you'll have to run this somewhere to a drain. This is not going to be an acidic liquid coming out of here. All we're doing is this is the condensation that is made when we run the heat pump, comes off of the coil and runs down into here. And once in a blue moon, depending on if you have it vented somewhere outside, it may go into a defrost mode to melt any potential ice off of the coil on the heat pump. So this is important. We also give you a couple of red wires here too if you need an additional overflow sensor. That will let you know what's going on as we tip over this heat pump water heater. But just spin it back around for you. So you get it all hooked up from a plumbing side, right over there by Rob, or your wires for your 30 amp circuit that's going to come to this heater. And then what's next? So on this unit, this is just a standard control. It's going to be in hybrid mode, and you'll go ahead and push these buttons. This has been around for a while. A lot of guys have seen this, but I just changed the screen here for you. On the new one, okay, we do have what's called ICOM. If you deal with any of our larger commercial units, our BTH models, anything that's a 300 series unit has this ICOM technology in there. So basically what you can do with this ICOM technology is it gives you smart connectivity, and you can look at this water heater from afar. So that's a difference, all right? If that's something that people are into, that's something that people are into. You can also see pretty well here that I can't do it. It won't work. My laser is not working. But anyway, you can see how they rotated everything to the front compared to this unit, right? Here's my hot water tapping way back here. On the new one, it's right here next to the relief valve, right? The cold water tapping is brought out here also. And the electrical connections have been brought around closer to the front. So that gives us that opportunity to really wedge it into a corner. You can see the top takeoffs there. So we have top and side, and then both your fresh air and your exhaust air. And I call it exhaust air. Also, all we're talking about here is we're pulling air. If we don't have enough cubic feet in this space and we want to pull air from another part of the home, we can just purchase normal ductwork and duct it in there. You no longer have to buy a duct kit for the AL, and you'll bring the fresh air in. We'll run that across the heat pump coil, and then we'll take the air that we've just pulled the energy out of, and we're going to send that back out through the exhaust duct. So on the intake, that's where the little screen is. That will have to be cleaned every once in a while. And one of the biggest advantages here is now we're down to 37 degrees and we're 45 decibels. And our clearances have really, really been shrunken down. Why do I keep losing control of my clicker? There we go. So there's just a comparison, side-by-side comparison. This is what we currently offer on looking at the screen on the left-hand side, 51 decibel. So I'm talking probably in the 57 to 60 range.
Probably more.
Probably more,
Yeah.
right? We're a little bit more than that. So this is going to be 51 decibels. This unit, the AL, is 45 decibels. The ducking, again, is an accessory. The app and all the stuff for the control is an accessory. The new one comes with all that. The old one was a 3.45 efficiency. The new one is up to a 4.02. So I think you got a, what is it here? I wrote it up. It's a 3.8 on the 50, a 4.02 on the 66, and a 3.88 on the 80. So more efficient, little neater, tighter install, gives you a little bit of flexibility. The water detection is extremely important. And what does this mean to you? This gives you an idea of what the standard water heater costs to operate over 10 years is $8,530. So by going with the HP TS50, which is this version, you can see that drops it down to about $2,020. So there is a price difference between the standard electric water heater and a heat pump. There's no doubt there's a difference. That's where, you know, all of these rebates come into play. New Jersey is 600 plus the federal rebates. The lower Hudson Valley, let's say we go up to the Poughkeepsie, Dutchess County side, we cover all the way down through Manhattan, Long Island, and majority of New Jersey. So all of the New York regions there, the Con Ed regions, there's a $1,000 rebate plus the federal rebate plus the opportunity to capture some money back on the cost of the install. So there's a lot of opportunity to take this hybrid water heater and really drive it down to the price of almost where an electric water heater is. And you can see there, you know, you're talking, you know, over $6,000 in savings over 10 years.
Yeah.
That's money. That's not a $20 bill.
Absolutely.
You know, that's money. A couple other options up there too. You can just look at them. You want to take a screenshot. You know, this is information from A.O. Smith that they shared with us. You have a standard gas water heater, you're almost $4,000 a year to operate. With the heat pump electric, you're still a couple $1,000s less over that 10-year period. If you look at your, you know, if you really look at your CO2 emissions, which is really what's driving this electrification, you know, you can see in the blue just the repercussions of using a gas appliance compared to an electric heat pump appliance on your tons of metric tons of CO2 emissions over a 10-year period. So this is kind of what's driving it. And then if you go one step further, the gentleman I was with yesterday, adding the solar to his home, you can see it even drives it down more over that 10-year period. And there would be other things calculated in there. Obviously, if you put solar on your home, it wouldn't just be for a hybrid water heater, but you can see that we really drive it down.
Yeah, absolutely.
Chugging along. Anybody questions? Nothing's popped up. You got questions?
Is there a formula to figure in the cost of reheating the air in the heat sink?
Yeah, so that's a really good question, and that's one we struggle with all the time, right? Because if we're taking conditioned air and running that conditioned air across this heat pump coil, we're going to be offing cooler air into that space. So that is a little bit of a concern. We could probably get a rating, you know, of run hours of how many BTU we're actually exchanging. I know on these units it was in the neighborhood of, you know, somewhere around 4,000 BTU an hour based on a specific temperature, and I think that was I think that might have been at 52 degrees. We could do some more digging on the new unit. I don't have any of those specs on the new unit right now. Actually sat through a webinar yesterday for the new unit, but I think it was, this one was like at 52 degree inside temperature. It was putting 4,000 BTU worth of heat energy into the water. So we'd be offing approximately that 4,000 BTU into the space at a cooler temperature.
Yeah.
And realistically, we're really only looking at, you know, in the neighborhood of, and I wrote it down from yesterday, I think it's like 9 to 12 degree delta across that coil.
Right.
So incoming air, we're going to put it out at about 9 to 12 degrees cooler than it was coming in. So I hope that answered the question. More to follow on that as we get more information out of AO.
Does the manufacturer make a duct attachment piece for the outlet? I've had to make ductwork
Yep.
made several times.
Right.
To duct
So-
cold air out of the room.
Right, so this unit right here, we have a ducted kit that you purchase for this unit. The new unit has takeoffs right on top of it, has an inlet air and an exhaust air. You're just going to buy standard ductwork to hook to the top of that unit and put it into whatever space you want. So that's another feature where, you know, AO didn't want to have you purchase more equipment from them. You guys have ductwork at your shop or at your local distribution center that you can grab that ductwork once you know what you need, elbows, you know, 45s, whatever. And there's lengths and limits to that, but we do have that.
Do you have info on commercial heat pump water heaters like the CHP 120?
As far as efficiency numbers, or we do have a CHP 120. I don't have any of the numbers in this presentation, but if he wants to send us his email, we could see what we can dig up on that and send it out. So, yeah. Caught up? Okay, we're going to keep going. Power's power. We're not going to waste a lot of time on that. Your clearances, again, that zero clearance, right? T&P valve, make sure we're piping everything to code. Expansion tanks are very important here. You have an opportunity to draw this down quite a bit. And if we do pull, you know, if we do what's called a deep draw and we make the whole tank cold, well, we're going to heat that tank back up again. So let's say we take it from 50 degrees and we elevate it to 120. You know, we got a lot of expansion going on there. So, you know, usually under 50, we'll stick with a 2-pound expansion tank. Over 50-gallon water heaters, we want to go to the 5-pound expansion tank. So critically important. Put it on the cold water side. You know, most municipalities have either put a check valve in place or a backflow preventer in place, something that's not going to allow, when we heat this water up, usually the expansion would push back against the town water or you know, whatever you're working with. Now you're just going to create additional pressure within the system and stress out all your faucets and everything else within your plumbing system. So AO Smith across the board, maximum working pressure on a tank is 80 psi, even though we recommend, you know, between 50 and 60 psi. So if you're seeing some of those higher numbers, definitely want to put a pressure reducing valve in place. It will just make the water heater live a much more comfortable life.
Yeah, one thing to add to that, even if you are able to, you know, push back towards city water, you don't know at some point in time if they are going to put a check valve in that system. So it's best to just avoid it altogether and install the expansion tank.
Probably the only thing really here, this gives you a good view of the upper connections, and the little elbow sticking off of there, that comes with the unit, and that's what your 5/8 OD or ID hose goes right up over that barb fitting, and if you have to extend it, that's 5/8 ID. Here's the recommendation. You need 450 cubic feet of air to run across this heat pump. This current unit we're looking at needs 700 cubic feet of air. So part of the change in the water heater was this has a blade fan. We've changed that to more of a squirrel cage fan, and that has reduced the noise dramatically and the amount of CFM, or the cubic feet of air we need within that space. So that's a big upgrade for us. Again, there's your airflow in and airflow out. That's where, if you want to duct it, that's where you will duct it. And if you're 5-inch, you know, 6-inch, 7-inch, or 8-inch, that's going to give you your dimensions. Really keep this as short as you possibly can. You know, every foot of ductwork you add onto this unit, you're starting to diminish its efficiency. So rigid duct is better. It's less likely to have, all the spirals in it. I wouldn't use a rigid duct that looks like that, like a dryer vent. I'd use regular, whether it's 26 or thinner
pipe.
gauge pipe. That's your best bet. The less restriction, the better. And we want to make sure that the air is critically important. If you don't have enough air going across this refrigerant circuit, the heat pump side, you're going to end up with thermistor error codes that are going to be nuisance problems for you. So we want to make sure we hit these numbers.
Yeah, plus the coils could end up freezing.
Yeah, right. And defrost mode, and then we're back to electric water heater.
One thing, and I'm not too sure about, I want to get an answer to this, but, let's say we are in an excessively warm boiler room situation and we have these metal ducts coming off the heater. We may want to, wrap it with some sort of insulation on the outgoing side.
Well,
That might
yeah, we
condensate.
talked about that yesterday on the webinar with them. So you need to understand where you're going to run the, I'll go back to here. You need to understand where you're going to run these ducts, right? I'm not going to run these ducts out through, let's say, a crawl space that is unheated and sealed and unheated.
Sure.
Because in the wintertime, I'm pulling 30-degree air across there, and then I'm bringing it into the heat pump, which, I'm not going to get much performance out of it. I'll still get some, but not much, right? This heat pump only wants it work down to 37 degrees. If I change the ambient temperature within that compartment to get me down below 37 degrees, I now become an electric water heater. So it's critically important to know and understand where are these ducts going. If I'm in my basement and I'm going to pull air from, a room above, it's conditioned space. Everything conditions are close to the same.
Sure.
So just know where you're pulling that air from and know what the effects of that will be based upon where am I drawing the air, what's it look like, what's it feel like coming in, and will I benefit, will this heat pump water heater benefit from that air that's going across it. All right, and then if you are short on the amount of cubic feet of air that you need, we do give you some options here. You can add a low and a high vent into that space. If you only need one, you always do it at the top, and you can run one pipe in, let's say, or one pipe out. You're going to exhaust it out. You'll pull it from the house and then exhaust it out, and then you could always do the two-pipe system like we're showing you over there all the way to the right. So just some different options. Not everywhere do you have 450 cubic feet of free air that you can just grab onto.
Sure.
Can you recirc with a heat pump, tank style water heater?
Yeah, absolutely.
Yeah, absolutely. One thing we want to do here, though, is we want to make sure it's not a 24/7 run cycle. We want to make sure that it's either controlled with an aquastat or, like a smart plug or something, a Takeo smart plug. The reason for that is if we, and the recirc line absolutely positively needs to be insulated, because on recirculation, all we're really doing is calculating, how much am I losing on that loop of recirculation, and what does this heat pump water heater have to put back into the tank to offset that loss. So we want to eliminate as much loss as we possibly can by insulating the line, and then we want to monitor the temperature, and we want to set that somewhere between 10 and 15 degrees below our target temperature here. So, I know people want hot water right now. That's the world we live in, and that's great. Less waste of water. Average family of four can waste 12,000 gallons of water waiting for hot water a year. So take the opportunity, if it's going to be there, to have a recirculation, a dedicated recirculation line or a crossover valve, whatever it might be. Just make sure that we're controlling that with some type of a smart device, whether I'll call an aquastat a smart device, but a smart plug or something along them lines, where we're pulsing or we're running so many minutes per hour instead of 24/7, 365, because you will just take the efficiency right out of this unit. So if we're going to sell high efficiency, let's sell a high efficiency system, and attach a Takeo smart plug, a 00E circulator, to it, and really let it run to its optimum efficiencies. So this is critical, and we don't really want to kill you guys with PowerPoint, but there's some stuff in here that's I just want you to see. There is a battery backup in here, so if you lose power from the old ones, would hold them for about 24 to 48 hours, all your settings and the control. Here we have a battery backup now, so we can extend that timing if we have a crazy storm. This weather, this winter, who knows what's going on. If we're going to get hit with a storm, you lose power for extended periods of time. This unit, the AL, has a backup in it, battery backup in it. One thing to recognize, though, is when you first install this and you turn it on, it's going to be about a 7 to 10 minute self-diagnostic check. It's going to run through a whole series of checks before it allows the unit to start. So, we're the Fujitsu guys. When you turn a Fujitsu mini split on, it's 2 minutes and 20 seconds before that unit activates. And for an installer, that's like, the longest 2 minutes ever. Well, now it's going to be the longest 7 to 10 minutes ever when you turn on this heat pump hybrid water heater. And every single time you power this down, it's going to go through the same 7 to 10 minute startup cycle. So it'll come on in hybrid mode. Target temperature from the factory, you can see there, is 120. And this is what's going to go on. Looks like you have a question there. You good? You're good. Okay, so we'll keep going. Anything you want to add there? I mean, that's
Yeah, no, it's pretty cut and dry. Yeah.
pretty cut and dry, right? All right, so this right here, dry fire protection mode. This is going to be bouncing across the screen. That's what that means. So what's going on right then and there is that we're making sure, like, you fill this tank up, it fills from either the top or the bottom, but the cold water always goes to the bottom and comes back up. If you don't have a hot water faucet open, you may have air trapped in this upper portion of the tank. And to prevent dry firing, we'll pulse signal to this unit, and then we're going to give you this dry fire protection symbol. That's what that symbol means, is that you are potentially going to dry fire this unit. So we've compressed air in the top of this tank. The tank is not completely full of water. So this is the signal to let you know that you need to purge out that air from the system. So you're going to want to go open up a large volume drain, something without a screen in it probably, and let it drain out, and then wait till you get a good flow of water for a couple of minutes. And that should all go away, because now we've recognized that we're actually pulsing that element, and we're pulsing that element into water. We have something that's taking the energy off of the element. So we put this dry fire protection into the heat pump water heater also. So another real nice feature on this unit. And you've probably seen some stuff about California over last 6 months or so, where people were losing their air conditioning and everything because they signed up for this smart grid device. And we do have a smart grid device. I don't know how soon we'll see that happening here. It probably is starting to take place as we speak, but we can put this CTA 2045 adapter right into under the control there, and that allows the electric company to know you're hooked up to the smart grid, and they can run this heat pump water heater depending on outdoor temperature. If it's during the day, they're probably going to slow this thing way down and let the air conditioning systems run, and then at night they'll let this heat pump crank away and make your hot water for the next morning. So we do have that ability built into the new Voltex ALs. This, like I said, this may be happening sooner than later. Just a heads up, it is available. So this is the leak detection sensor that comes with the unit. It has a little terminal right next to the lower element where that plugs in. If you pull that black cover off, you'll see behind there's a Molex connector where that plugs in and goes back up to the control. But that clips right onto the side of the water heater. Those two little talons sticking down there, that's what's going to sense the water if there's a problem, and shut the unit down, give you an alarm, let you know that something may be leaking. This is if you want to take a snapshot of that, that is the shut-off device that's available. That will work in conjunction. That is where the Molex plugs in. You've seen the other Molex on the other photo. There's a Molex connector that goes between the control and this leak shield valve. You'll put this directly on your cold water main, and that will shut off the main if this leak detector sees water. It will send that signal up to the control through that Molex connector to the Molex connector on the leak shield. It will take vertical right there. You see it says open. It will take and rotate that to the closed position, and that will shut your mains off. So if the leak is at the bottom of the tank, the most you're going to have is the volume of the water in the tank, and it will come out at a much slower pace because there's not 50, 60, 70 psi behind it. If the leak's at the top of the tank, you'll just have a little bit of a leak, and then it'll sit there with a full tank. So that's a good device to have. This just goes through and talks about, what goes on with the refrigerant circuit. But again, you do not have to be a refrigeration expert to install a hybrid water heater, so I won't spend much time here. Okay, this just talks about where are we getting this energy from, right? If I'm boiling water, you use the old BTU theory, right? 1 BTU to raise 1 pound of water 1 degree, and that works from 0 to 211 degrees, and then you're going to need almost 1,000 BTU to go from 211 to 212.
Someone has a type of refrigerant?
134, I think it's in here. It's 134. Okay. That just talks about where the, sensible heat and latent heat, where that comes from. This is a nice diagram here. So up on top, that's where our control is. Behind the control is where the heat pump is, the compressor, the coil, the fan, the thermistors, everything for the heat pump is up there. And then that basically is the condensing coil that wraps around the outside of the tank, and then we insulate over that coil. And that's where we're transferring the refrigerant heat energy into the tank and heating up the water inside of the tank.
Yeah. The efficiency, that's what we spoke about before with John's reference about the dollar bill in the machine. So that's basically just that in wording.
And then this just goes more about the refrigerant circle and, the refrigerant cycle and what happens. Again, we're not going to, that's the top of the water heater. If you see right there, that little horseshoe looking thing, the copper that's pointing down, that's going to the coils that we just looked at a second ago around the unit. And then it'll come back up and go through the coil up here, through the compressor there. And that's going to be your refrigerant cycle. We're going to send, we're going to change pressures, put out hot gas. We're going to put gas out there almost at 200 degrees. So that's what takes place when we're making that hot gas and transferring it into the tank. There are 4 modes of operation. This unit has 4 modes of operation. The new one has 4 modes of operation.
Yeah. So just basically we have 4 modes: heat pump, hybrid, electric, and vacation. You can set, just by hitting the mode button on the screen, whatever operation you're looking for. I would always, up here, I would recommend probably putting it in the hybrid mode because, there's going to be a lot of instances where we're not going to be able to pull enough heat from the air into the tank to be able to satisfy the demand. So hybrid would probably be recommended. But we also have the electric only mode. So just in case something happens with the refrigerant cycle, we can always, just go back into that electric mode. And then they also throw in a vacation mode, just in case you're not going to be around for a while, up to 99 degrees, and that'll keep the tank temperature at around 50 degrees. So we have that.
Whatever room temperature is, that's where the tank will be.
Right.
Just on any one of those modes, just remember if the heat pump does fail, as Rob said, it's going to go into electric backup mode. You won't necessarily be without hot water. So it's almost like you have a redundant water heater without having 2 water heaters in the space.
Sure.
So that's another feature, when you're talking to the end user, that's another feature that you can use. So heat pump will only operate if the ambient air temperature is 37 to 120 degrees. So keep that in mind. We also have to look at the tank. The average tank temperature must also be above 55 degrees for the heat pump to operate. So if we just install this, we got that 7 to 10 minute wait period. Let's say we put 50-degree water in there. It's cold out, not like it's been here in February, but it's cold outside, and we're getting cold water from the town, and it goes in at 50, 51 degrees. we're going to go into an electric mode first until we have an average across the tank of 55 degrees. Once we get an average of 55 degrees across that tank, then we'll allow the heat pump to kick in. So two things we have to understand. Well, three things. 7 to 10 minutes, it's going to run its cycle checks. Ambient air has to be above 37 degrees, and water temperature has to be above 55 degrees average, and then it'll allow the heater to go into heat pump mode. When you first turn it on, let's say we are above 37 degrees, the heat pump has a green light there, but the water has not gotten above 55 degrees within the tank yet. It's going to hold the heat pump off until it gets there. Then the heat pump will come on, the electric elements will shut off, and we'll go into heat pump mode as we're making that up.
Yeah, and you'll be able to see on the screen as well if that's what's happening. If we fall out of one of those parameters, whether it's below 37 degrees, above above 120 degrees, or the water temperature is below 55 degrees, you'll actually see an HPO come across the screen. That is not an error code. That is a system function. It's just making sure that it's protected.
That's what we'll see on this unit. If they go to the Voltex AL, we'll see a 028.
028,
Right. So just so they get the difference.
Yep.
Chris, you got another one?
Is it recommended to wrap the heater in unconditioned basements? Because the temperature can rise in New York and is stored in unconditioned basements. Should we always oversize each heater?
Yeah, I mean, normally when we say unconditioned, I wouldn't install this anywhere you have the opportunity to drop below 32 degrees, because water will start to freeze at 32 degrees and could create damage to the water heater. But this has about a little over 2 inches of heavy, dense foam around the outside of the jacket. The jacket is 2 inches plus thick. So around the tank, we do have a lot of insulation. Also, this current heat pump we're looking at up here, the heat pump won't turn on until 45 degrees. The new one won't turn on until 37 degrees. So if you know you're going to be at temperatures below that, it may not be the right appliance for the application.
Yeah, sure.
Got another one, or we're good? Okay, keep them coming. Great stuff. Thank you. Okay. This is just the hybrid, what the drops are and everything for it to drop out of these different modes. So defrost, again, if something in the refrigerant cycle sees that we're going to get down into that 32 degree range, we have the potential to create ice on the coil. It'll go into a defrost mode. Another reason why we need that 5/8 ID tube coming off of there, so we can drain any of that off as we melt it. This is, okay, go ahead. Another question?
If I duct this to the outside when outdoor temp gets below 37, should I go to element aux?
Yeah, so if it gets below 37 degrees and you're pulling air from outside, if this area that we're looking at right now, this is a view from top down. There's the fan. There's your evaporator coil and the compressor and all the thermistors. We're looking down at all of that right now. This also has a sacrificial anode rod, which is important. And this will actually let you know when that sacrificial anode rod is used up. So it'll tell you on the screen when it needs to be changed, which is a great feature. But if we get down below 37 degrees and the heat pump sees that we're below 37 degrees, yes, it will shut the heat pump off and it will go back to working off of the 4,500 watt elements, and it will become an electric water heater at that point. So if your best bet is to duct the air into the room, bring it all the way down to the floor, and then turn around and come back up at least 4 feet, that will create a cold air trap. That'll be putting the air into the space. It won't be putting the outside air directly to the heat pump. Maybe that air will have a little time to heat up before it makes it to the heat pump, and that will make it run more as a heat pump than a electric water heater.
Yeah.
So getting the air in and out of these is critically important, and I know New York City is really driving towards electrification, so that's something to take into consideration when they're doing the install.
Yep, well said.
So here, this just goes through the heat pump. We got a bunch of thermistors on there that are monitoring everything that's going on. If you ever have to troubleshoot these, it'll give you a code that'll identify which thermistor is having the problem, and it's taking an ohm value is really all you're doing here.
Yep.
So again, you're not touching a refrigerant circuit. You don't have to have special tools. You don't need any of this. You will need a multimeter, which you have hopefully anyway for troubleshooting other components. Okay. Anytime you're working on it, you always want to make sure your power is off. That's important. This is just a cover right here removed off of the unit, and behind there it gives us our thermistor, our thermal ECO, the overflow, our temp device that will shut it off if we over temp. If you ever have to get anything in behind here, it's one screw. Take that screw out, the panel will lift off on the new ALs. And then here we're showing you the element. That's a 4,500 watt element. There's your ECO cutoff. And there's going to be a little bit of foam insulation there that covers that up. And then you'll have the black cover that goes on the front to make sure this thing is as efficient as it can possibly be. And then right here, I talked earlier about that water device that senses water. That is the lower element that we have the cover off of there, and that little Molex connection you see right there, that's what goes down to the water detection sensor. That's your element, and then that's your condenser coils. There's 6 wraps of the hot gases that's running around the bottom of the tank right there above the element, and then you see another couple below the element. So we're putting that hot gas, wrapping it around the steel tank, insulating the back side of it, and we're forcing that hot gas refrigerant to transfer its energy into the water. So that's where we have the largest delta. That's where we're going to get most of it to transition over. And then there's a troubleshooting section, which we're not going to get into the troubleshooting section. But what that does is that just tells us, anytime you want to see what's going on, you just hit the enter button on the controller. That'll wake the control up, and you can see exactly what's going on within the control. It's all going to be number codes, and the number codes will reference you to whether it's a thermistor, whether it's an upper heating element, whether it's a lower heating element. This is going to point you right to the direction of the component that has failed. So that's a brief overview. If anyone needs additional training or wants additional training, we do have this version that's mobile. So we can do other stuff with it.
Yeah, we can come to you. You can come to us. We're always open for more training. This is basically what we do. We love reaching out to you guys, and giving you the ins and outs of the equipment and making sure you're comfortable with it. So.
Yep, and I know we're talking, mostly electric hybrid stuff today, but if you're in the need for tankless is a big deal. We do have about 4 more than 4 versions, but we have a single, a dual, and a 4-tube electric tankless unit. And then we have the gas-fired units. This is the X3 version. This cartridge right here, this allows you to not clean the water side of the heat exchanger for 15 years.
Maintenance free.
Maintenance free water side for 15 years. So that's what the X3 is, 3 times longer than a normal tankless water heater. That's because of this technology right here on the unit itself. So if you need a tankless and you're not a big maintenance type company and you don't like going out there and having to flush, a vinegar solution or a lightly acidic solution through the heat exchanger to clean the heat exchangers, we now have a cartridge that goes on our units that gets you 15 years no waterside maintenance. So with that being said, we took up about an hour of your time, and we appreciate every minute of it. Hopefully this has answered a few questions for you. If you need additional questions, you can reach out, email us, let us know what you're after. You will see some additional rebate information coming to you via the email that you supplied us when you signed up. And Chris, if you don't have any other questions, we're in good shape. Thank you, Rob. Thank you, Chris.
Thank you, everyone.
And we will see you next Wednesday.
What do we have next Wednesday?
What do we have next Wednesday? I'll tell you that in 1 second. So today was heat pump water heaters. Next week is Rick and Anthony with Space Pack,
Space pack.
lowering the temperatures. So thank you, everyone. Everyone from Wells Darby, we thank you for spending some time with us this morning.
Yes, absolutely. Thank you very much. Truly appreciate it. And feel free to reach out to us at any time.
Thank you.